Hi children, good evening. My name is Panchrinwas and today I will discuss about George. Do you know anyone who is George? Okay, now I'll tell his full name, George Ohm. I think now you'll get it. George Ohm. Ohm. Ohm's Law. Right. You all know very well known about the Ohm's Law. Today we'll discuss about what is exactly Ohm's Law with a small example. Okay. First, let's get started. Ohm's law was created or invented or proposed by George Ohm. So it is called as Ohm's law. And what it states that, let's see here. Ohm's law means whenever a conductor is connected to some potential difference or a voltage, the electricity that is passing through that conductor is directly proportional to the applied voltage. That means whenever a conductor means current carrying material, whenever it is iron or nickel, anything which should be copper, anything, any material that should carry some electricity. See, whenever we supply, when we give some electricity, the electricity that is passing inside the conductor is directly proportional to the applied voltage. That means whenever the current increases, the electricity increases, the voltage also increases. Whenever the current decreases, the voltage also decreases. That's it. That's the point. Let's get deeper into the subject with a small example. Before getting into some example, let's figure out some formula. So we have three terms. Those are electricity. It is denoted with the symbol I. Electricity means current. And we have voltage, that is denoted with the symbol V. And we have the third term, resistance, which is denoted with the symbol R. So V is directly proportional to I. So V is proportional to I. We'll see here. Okay. So if we want to remove the proportionality symbol, we should put some equality sign so that we get the formula. So in order to remove that proportionality symbol, we need to add some constant, that is what, resistance. Okay, so now we'll figure out the formula. V is equal to I into R. That means voltage is equal to the product of, it means the multiplication of current and resistance. So if we want resistance, the I comes this side of the equation. Resistance is equal to voltage by current I. R is equal to V by I. So let's get into the example. I think you all very well know about the 5-star ad. There we can see two characters, namely that Ramesh and Suresh. Hare Ramesh, Hare Suresh. I think you all well know about that. So we have two characters here. One is Ramesh and the second one is Suresh. Okay. What are they doing here? Yes, we'll discuss. Okay. They are making some small experiment. What is the experiment regarding Ohm's law? To explain Ohm's law very clearly. Okay. Things we need. Okay. So what are the things? The cell means the battery, and the nichrome wire, and a milliammeter. Ammeter is the device which is used to measure electricity. Okay, current. And voltmeter. Voltmeter means which is used to find out voltage. Yes, I think you all know when. So at first they set up the equipment with a single battery cell. Okay, single battery connected to the circuit, and a voltmeter is parallelly connected to the nichrome wire, and the ammeter is connected to the circuit in a series connection. Also we can find a small switch. So switch is the connection. It connects the connection, or it completes the circuit, or it discontinues the circuit. Okay, it breaks the circuit or it connects the circuit. That is the purpose of the switch. So they're switching on the circuit. Now what happens now? Any guess? Okay. Electricity and the voltage are traveling through the nichrome wire. The nichrome wire. So the readings of electricity, current, and the voltage, potential difference, both are the similar other names. They are being recorded in the meters, right? You can observe the differentiate in the readings. The voltage and the current are passing through the nichrome wire and being recorded through the meters, which we connected the voltmeter and the milliammeter. The ammeter recorded 120 milliamps. That means 0.12 ampere current, and the voltmeter recorded 0.3 volts. So let's get it some more interesting. What's that? So we'll add one more cell to the circuit in a series connection, right? So now we'll record the data, what is happening. So the Ramesh and Suresh got very excited. Again, the electricity and the voltage passed through the nichrome wire and been recorded through the ammeter and the voltmeter. Now what are the readings you can observe in the animation? When the second cell is added to the circuit, the readings change. What about the voltage? The voltage increases from 0.3 volts to 0.5 volts. Okay, we'll do one thing. Let's get this thing very interesting, somewhat, little bit interesting. We'll add one more cell to the circuit, right? So Ramesh and Suresh took one more cell and added to the circuit. You can observe in the animation video. What happens now? The electricity and current again pass through the nichrome wire and been recorded through the meters. What are the meters? The milliammeter and the voltmeter, and the readings again increased. Milliammeter readings are 0.3 amperes and the voltage are increased to 0.75 voltages. Now let's get into some calculations. We have the readings, right? So we'll do some calculation part. As we know that the formula of voltage, V is equal to I into R. It means the product of current and resistance. And what we have the values of voltage and current. So we want resistance, right? So we'll check the resistance. Resistance R is equal to, we know that, V by I. So for the three readings, for the battery 1 and 2 batteries and the 3 batteries, we'll have the readings and we'll do the math. Wow, I think you are amazed. Why? Because the resistance for the three readings are similar. Why not? It's almost same. The 2.5 resistance, 2.5 ohms resistance is having, the nichrome wire is having the 2.5 resistance. So here the resistance is constant. Hence we proved the Ohm's law. What is the constant? The resistance is the constant. And what are the variables? Voltage and the current, right? So whenever a conductor is in a circuit and the electricity and the voltage are passing through it, the voltage is directly proportional to the current and the current is inversely proportional to the resistance. Okay, so the resistance of any material in the universe remains constant. It does not change. Even though you increase the voltage, the current or any other properties, the resistance of the material still same. Only under one condition, the temperature should be constant. You should not increase the temperature of the material while conducting the experiment. This is a note. Thank you. Have a nice day.